This will be part 2 of the Gatling gun Whirligig. The first part was how I made the propeller and the barrel tubes. This will be focused on the back half of the Whirligig. I noticed when I was outside we have a new family of ducks in our neighborhood. This aluminum angle came with the DRO system that I bought for my milling machine. It didn't fit my application on the milling machine, so now I can repurpose it for something else. I thought about assembling everything with pop rivets, but instead I'm using number 440 stainless steel hex head screws and number 440 stainless steel round-based weld nuts that I got from at MasterCar. I needed something sturdy for the base for the pivot point, so I used a piece of 1/4 inch thick aluminum plate. And I have a thicker piece of aluminum, and this will be for the shaft on the bottom for the pivot point, and also the shaft for the propeller. I'm going to use a piece of scrap 1/2 inch stainless steel for the pivot shaft. And I'll just thread it into the bottom of the housing. Because the thick piece of aluminum that I had was just scrap, I'm just going to square it all up in the milling machine. Next, I need to mount the pivot block on the base for the housing. This will be the hole for the propeller axle, and it'll be held in place with 2 set screws. Next I need to make a spacer for the propeller axle so the propeller doesn't hit the housing. Next I need to make a spacer for the top of the pivot shaft and a locking collar for the bottom of the pivot shaft. I shortened up the 1/2 inch shaft, and here it is with the bearing sandwiched between the spacer and the locking collar. The bearing is a sealed bearing with a 1/2 inch inside diameter and a 1 1/8 outside diameter. Next I need to make the mounting post that will accommodate the 1 1/8 bearing. I'm going to size the aluminum to fit inside a 1 5/8 galvanized fence post. This part of the hole will be 5/8 in diameter and the full length of the 1/2 inch shaft. Next I need to use a boring bar to make the hole big enough for the locking collar. Next I'll use the boring bar for the 1 1/8 bearing. And the hole will be 5/8 of an inch deep, which is the thickness of the bearing. I taped a 1/16 inch thick piece of aluminum to a block of aluminum to use for a wind vane to see if it would steer the whirligig in the right direction for the wind. It looks like it's going to work, so I need to figure out some way to mount it on the top of the whirligig. It looks like the mounts for the wind vane are going to work, and it still steers into the wind like it should. Now I'm going to put 3 set screws in the mounting post to lock the bearing in place. I shortened up the wind vane, and off camera I balanced it at the pivot point with scrap aluminum on the tail end until I got it to balance. I need 33 grams on the tail end. So I found this piece that I can trim a little bit off and mount it underneath the housing so it'll be more streamlined and less wind resistant. Here's how it looks mounted under the housing. I know it's overkill for a Whirligig, but the fact that it's made out of aluminum and stainless steel, it should last forever.